All right, continuing with section 6.7 on financial models, we want to look at the present value formula theorem. Now, all this says is if you know how much you want to have in the future, can you compute what you need to invest today? So you just take the two formulas you were already given for the compounding and the continuous compounding and rearrange them solving for P. And you would get P equals A divided by 1 plus R over N to the NT, but we can write that as 1 plus R over N to the negative NT just to get this expression out of the denominator. Okay, and likewise solving the continuous compounding for P, you get P equals A divided by E to the RT, which would be the same as A times E to the negative RT. Now, could you just use the other formula? Yes. If you knew A and you were trying to find P, you could just plug everything in you knew and solve for P, right? This is just what the equations look like. You were not expected to know any of these equations for a test or a quiz. In the homework, you may be looking them up, but they are provided in tests and quizzes. Okay, how long does it take for an investment to double in value if it's invested at 4.5% per year compounded monthly? So this is not continuous compounding, so let's go back to our original compound interest formula. A equals P times 1 plus R over N to the NT. And let's see what we know. Well, all we know is we're going to double the value. So we're going to start with P. How much are we going to end up with if we double it? Well, our A is just going to be twice what we started with. So 2P equals P times 1 plus R over N. Do we know R? Yes, we do. We know R. It's 4.5% or 0.045. Do we know N? Monthly, N equals 12. See, R equals 4.5%. So this is 12. N equals 12. Do we know T? Well, no, it says how long. That's what we're looking for. Okay, we have two variables, but notice if I divide both sides by P, what happens? It's gone. What does that tell us? That tells us it doesn't matter what you start with, the time it takes to double is the same. So where's the variable? It's in the exponent. So what do we have? We have an exponential equation. All right. So this is 2 equals, simplifying that, I get 1.00375 to the 12t. To solve that, I'm going to change it to a log equation. So 12t equals log base, what's the base? 1.00375 of 2, right? This is the base of my exponential, so it's the base of my log. So in other words, divide both sides by t. T equals the log of base 1.00375 of 2, all divided by 12. Well, to calculate this, my numerator is going to have to be the log of 2 over the log of 1.00375. Use the change of base formula, and then I'll divide by 12. We need to get to an actual number and round to tenths, right? So I had to use change of base for this. You could use natural log, and then I'll divide by 12. And let's see what I get. T equals 15.432, or approximately 15.4 years. So if I have these terms, monthly compounding at 4.5% interest, it doesn't matter what I invest, it will take me 15.4 years to double it. What if I had wanted to triple my money? What would be different? Yeah, I'd just say 3P equals P, right? Okay, A would be 3p. All right, part B. If you have $1,000 to invest at 5.5% compounded continuously, how long before you have $1,200? So the future amount is $1,200. The present amount is $1,000. The interest rate is 5.5%. And the question is how long? Compounded continuously. So this is A equals P times E to the RT. So A equals P times E to the RT, 0.055. Divide, we need to get the exponential part by itself, divide both sides by 1,000, and now write it as a log. So our exponent, our y, is 0.055t equals log base e, that's ln, of 1.2. So t equals the natural log of 1.2 divided by 0.055, rounded to tenths. Okay, so this comes out to be 3.314, or approximately 3.3 years. So to go from 1,000 to 1,200 at this interest rate, compounded continuously, it's going to take you 3.3 years.